Now we go to the another example. Last time we have seen the example d2y by dx square plus 2 dy by dx plus y is equal to 2e to the power 2x. Now we want to see the another example. Solve the equation d2y by dx square plus 4 dy by dx minus 12y equal to e to the power 2x. Here, this is the given differential equation. We write this differential equation in the symbolic form as to be d square plus 4d minus 12 of y is equal to e to the power 2x. From this, we consider the associated homogeneous differential equation in which we consider the right hand side to be 0. Means the associated homogeneous differential equation is d square plus 4d minus 12 of y is equal to 0. From this, the auxiliary equation is m square plus 4m minus 12 is equal to 0, and we know that how to find its factor. The factors are m plus 6 and m minus 2, and from this the value of m are minus 6 and 2, and therefore we can say that the auxiliary equation have the real and distinct roots. Therefore, the complementary function of this non-homogeneous differential equation is given by yc is equal to c1 e to the power minus 6x plus c2 e to the power 2x. This is the complementary function of this non-homogeneous differential equation. And how to obtain this, we have seen this in the previous topic. From this, we consider the homogeneous linear differential equation and we write the solution of it, which is the complementary function of this non-homogeneous differential equation. Now we are interested in finding the particular solution, or it is also called as the particular integral of this non-homogeneous differential equation. We have to take yp is equal to 1 upon f of d operate on Q of x. Here f of d is d plus 6 into d minus 2 and Q of x is e to the power 2x. Therefore, we obtain yp is equal to 1 upon d square plus 4d minus 12 operate on e to the power 2x, and this is equal to 1 upon d plus 6 d minus 2 operate on e to the power 2x. We use the two methods. First method is partial fraction method. Remember that in the examination, if you want to solve the such type of differential equations, then do not use both the methods. You use any one of the methods which you think that it is easier for you to solve the examples by using that method. Now here first we see the partial fraction method. With the help of this, we write 1 upon f of d into 1 upon linear factors of f of d. Means we write 1 upon d square plus 4d minus 12 equal to 1 upon d plus 6 into d minus 2. Denominator have the linear and distinct factors. Therefore, by partial fraction method, we write this is equal to a upon d plus 6 plus b upon d minus 2, where a and b are constants and we want to find these constants. Now we take the LCM of denominator as to be d plus 6 into d minus 2. Then we multiply a by d minus 2. The numerator is a into d minus 2 plus b into d plus 6 divided by d plus 6 d minus 2. then both the sides of this denominator gets cancelled, and we obtain this equation 3 as to be 1 is equal to a into d minus 2 plus b into d plus 6. Now from this equation 3, we want to find the value of the constants a and b. Now to find a, in this equation 3, we substitute d is equal to minus 6. If we choose d is equal to minus 6, then on both the sides of this equation 3, we obtain the left hand side is 1. There is no d is equal to a into bracket minus 6 minus 2 plus b into bracket minus 6 plus 6. But minus 6 plus 6 is to be 0. Therefore, we obtain after calculation a is equal to minus 1 upon 8. Now, in this, to find the value of b, for this purpose, we choose d is equal to 2 in this equation 3, or we substitute d is equal to 2 on both the sides of this equation 3. We obtain 1 is equal to a into bracket 2 minus 2 plus b into 2 plus 6. But 2 minus 2 is 0. Therefore, we obtain b is equal to 1 upon 8. And then we substitute these values of a and b in equation 2. And after that, we substitute these values in equation 1. Then we obtain particular integral yp is equal to in the bracket minus 1 upon 8 1 upon d plus 6 plus 1 upon 8 1 upon d minus 2 bracket complete. Operate this on e to the power 2x, and now we simplify this bracket, means we operate one by one on e to the power 2x. We obtain yp is equal to minus 1 upon 8 into 1 upon d plus 6, operate on e to the power 2x plus 1 upon 8, 1 upon d minus 2, operate on e to the power 2x. We get this. Now we operate one by one. For that purpose, we use the result which we have seen in the previous topic or in the previous lecture. 1 upon d minus a operate on p of x is equal to e to the power ax integration of e to the power minus ax into q of x dx. And here do not add the constant of integration, as we want to find the particular integral or particular solution. And this particular solution does not contain any arbitrary constant. Using that result, we are able to write this. This is equal to minus 1 upon 8. And if we operate 1 upon t plus 6 on e to the power 2x, we obtain e to the power minus 6x integration of e to the power 6x into e to the power 2x dx. Similarly, for the next term, 1 upon 8 e to the power 2x integration of e to the power minus 2x into e to the power 2x dx. After simplification, we get this. This is equal to minus 1 upon 8 e to the power minus 6x integration of e to the power 8x e to the power 6x into e to the power 2x becomes e to the power 8x dx plus 1 upon 8 e to the power 2x and integration of e to the power 2x into e to the power minus 2x becomes e to the power 0 into x, means e to the power 0 is 1. Since e is non-zero, therefore, this is the integration of dx. Now we evaluate this integral, very simple integral, and then we obtain this term. Integration of e to the power 8x is e to the power 8x upon 8, and integration of dx is x. After simplification, we get yp is equal to e to the power 2x upon 64 plus yp is equal to minus e to the power 2x upon 64 plus 1 upon 8x e to the power 2x. Now we obtain the particular integral. Now we write the general solution of given non-homogeneous differential equation as to be y is equal to yc plus yp. We obtain here yp by the partial fraction method. Now we again obtain this yp by operating this linear operator one by one. Now this is the general solution. This is yc plus yp. Now we see the another method. Second method, yp is equal to this. We write this fd, f of d has to be the linear factors. We get this. Now we operate first 1 upon d minus 2 on e to the power 2x. We get this 1 upon d plus 6 e to the power 2x integration of e to the power minus 2x into e to the power 2x dx. Again here we use the formula 1 upon d minus a operate on p of x. This is equal to e to the power ax integration of e to the power minus ax into p of x dx. Using that formula or that result, we write this step. Now we evaluate this integral. We get 1 upon t plus 6 e to the power 2x, and this is the integration of e to the power 0x is 1, means integration of dx is x. Now do not take outside this operator. We want to operate 1 upon d plus 6 on x e to the power 2x. Again we use the previous results and we write this is equal to e to the power minus 6x integration of e to the power 6x into e to the power 2x x dx. Then we obtain e to the power minus 6x integration of e to the power 8x into x dx. Now here we integrating by parts. We have seen how to integrate this using integrating by parts. We use this formula as to be integration of first into second term is equal to first term into integration of second minus integration of derivative of first term into integration of second term. Now here we choose x as to be the first term and e to the power 8x as to be the second term. Then by integrating by parts, we obtain e to the power minus 6x into bracket x integration of e to the power 8x dx is e to the power 8x upon x minus integration of derivative of x is 1 and in the integration of second is e to the power 8x upon 8. Now again we want to evaluate this integral. We obtain this e to the power minus 6x x e to the power 8x upon 8 minus e to the power 8x upon 64. Now we simplify this bracket. We obtain this is equal to x e to the power 2x upon 8 minus e to the power 2x upon 64. And then we write the general solution. We have seen these two methods to find the general solution of given non-homogeneous linear differential equation of nth order with constant coefficient. We have seen two examples. Now we see the third example. Solve the equation d2y by dx square plus 4y is equal to sec 2x. Whatever may be q of x. We see the general method. In this topic, we see the general method how to find the solution of non-homogeneous linear differential equation of nth order with constant coefficient. Now, after this, in the next topic, we see that some short methods. If q of x is of some particular type, then how to obtain its particular integral. We see these things in the next topic. Here in this topic, we want to see the general method, whatever may be q of x. Now here again we consider, we write this given differential equation in the symbolic form as to be in the bracket capital D square plus 4 bracket complete of y is equal to sec 2x. From this consider the associated differential equation as to be in the bracket d square plus 4 of y is equal to 0, and then we write the auxiliary equation as to be m square plus 4 is equal to 0. Therefore, its factor is m minus 2i and m plus 2i. Therefore, values of m are plus or minus 2i. Means roots are complex and non-repeated, or complex and distinct. Then we know that if we compare this with a plus or minus ib, then here a is 0 and b is 2. Therefore, complementary function yc is equal to e to the power 0 into x into bracket c1 cos 2x plus c2 sin 2x. But e to the power 0 into x is 1. Therefore, the complementary function yc is comes to be c1 cos 2x plus c2 sin 2x. I hope you understand up to this. You have seen this type of example so many times in the previous topic. In the previous chapter, you have seen this, how to obtain the solution. Now here, we want to see the particular integral yp is equal to 1 upon f of d operate on p of x, means 1 upon d square plus 4 operate on sec 2x. Now we factorize the denominator as to be d plus 2i d minus 2i, and we operate this 1 upon d plus 2i d minus 2i on sec 2x. Now here we operate one by one, or again we use the partial fraction method. Here we choose the partial fraction method. This is equal to 1 upon 4i in the bracket 1 upon d minus 2i minus 1 upon d plus 2i sec 2x. We know that by partial fraction method, we write 1 upon d plus 2i into d minus 2i is equal to a upon d plus 2i plus b upon d minus 2i, and find the value of a and b and substitute this, and then substitute this in this equation. Here I have written this step directly. You do all these calculations. Or here if we simplify the square bracket, then we obtain this is 4i upon d minus 2i into d plus 2i. 4i gets cancelled and we get the previous step. Now we operate this one by one on sec 2x. And this is equal to 1 upon 4i, 1 upon d minus 2i operate on sec 2x minus 1 upon d plus 2i operate on sec 2x. Now again we use the formula 1 upon d minus a operate on p of x. Using that result we get this is equal to 1 upon 4i into bracket e to the power 2ix integration of e to the power minus 2ix into sec 2x dx minus e to the power minus 2ix integration of e to the power 2ix into sec 2x dx. Now we first take the expansion of this e to the power minus 2ix and e to the power 2ix. We know that e to the power minus I theta is cos theta minus I sin theta, and e to the power I theta is cos theta plus I sin theta. Using that result, we write this value of e to the power minus 2ix as to be cos 2x minus I sin 2x sec 2x dx as it is, and for the next integral, the value of e to the power 2ix is cos 2x plus I sin 2x, then into sec 2x dx. Now sec 2x means 1 upon cos 2x. We simplify this bracket, we get is equal to 1 upon 4I into square bracket e to the power 2ix integration of open bracket. We take sec 2x inside of this bracket. Sec 2x is 1 upon cos 2x, and this cos 2x gets cancelled. We obtain 1 minus I sin 2x upon cos 2x is tan 2x dx minus e to the power minus 2ix. Similarly, we obtain integration of 1 plus I tan 2x dx. And now we will evaluate this integral. We get this is equal to 1 upon 4I into square bracket e to the power 2ix integration of 1 dx is x minus integration of I tan 2x dx is I upon 2 log of sec 2x minus e to the power minus 2ix in the bracket x plus I upon 2 log of sec 2x. Again, we have to simplify this. We write the expansion of e to the power 2 ix as to be cos 2x plus I sin 2x, and e to the power minus 2ix. Also we substitute here, and again we simplifying this, we obtain this 1 upon 4I is common, 2x sin 2x minus cos 2x log of sec 2x. This is I gets cancelled. We take this 1 upon 4 inside of the bracket. We get x upon 2 sine 2x minus 1 upon 4 cos 2x log of sec 2x. Now, if we arrange this, if we see this yp, and then we write the general solution is y is equal to yc plus yp. We get this c1 cos 2x plus c2 sin 2x plus 1 half x sin 2x minus 1 upon 4 cos 2x into log of sec 2x. This completes our this third example on this topic. I hope you understand how to find the solution of non-homogeneous linear differential equation of nth order with constant coefficient. And we have seen the two methods. Now, for practice, you may take these examples for practice to solve these examples by this general method. In the next topic, we want to see the some short methods. By using that short method, we are able to find the particular integral very easily by using this general method rather than this general method. Now we see in the next topic some particular type of this P of x. Means the right hand side is of this type. Then we use that short method. If this right hand side is not of that particular type, then in that case we use the general method. Okay, we stop our today's lecture.